Okay, thank you, Herb. Thanks a lot. We're here to discuss the results of our engineering study and the management plan and the proposal to go ahead and merge the Pinebrook water and sewer districts with the county. So as most people know, we performed an extensive engineering study, so I'd like to introduce the engineers who were part of that. They're here tonight. First, we have Erin Moore. She's with T&B Engineering, and she was the project consulting engineer. And we have Paul Malmrose, he's right here, also from T&B Engineering and also the project consulting engineer. We also have Bridget Barkley, the Dutchess County Water and Wastewater Authority, and Jonathan Churns, also of the Water Authority. And so the first thing I'd like to do, so I don't forget, is to thank you all for the very good work you're doing and have done, especially Bridget and Jonathan have done amazing work for the town of Hyde Park in many capacities. In addition to assisting us with this particular grant, they've also been a tremendous resource as we've dealt with the infrastructure, the existing infrastructure at the Pinebrook plant. So I also would like to take this opportunity to thank the media committee who have given up many hours of their time to be here so that the residents at home are able to view it. So just to give a little background, with the assistance of the Water Authority, the town obtained grants totaling $175,500 from the New York State Department of State's Local Government Citizens Reorganization Empowerment Grant Program. The grant provided for an independent engineering study of each of the town-owned water and sewer systems to determine how best to physically manage the equipment and infrastructure to ensure safe and reliable service. The town formed a reorganization study committee that includes representatives from the town board, myself, the advisory committee, and DCWWA staff, and they charged the RSC with the task of developing the reorganization study. The goal of the project is to determine whether meaningful benefits can be realized by dissolving the existing town Pinebrook Estates Water and Sewer District and transferring ownership and management responsibilities for the water system to the Dutchess County Water and Wastewater Authority. There are many benefits that we see to this transfer. The first would be improved efficiency and quality of service delivery. The second, professional management of long-term maintenance and rehabilitation of infrastructure, and improved efficiencies through scale and organizational structure. The third would be maintaining continuity. So everyone knows that the town board is elected every 2 years, and so there can be very significant breaks in the operation of town government, including the water and sewer districts. And the Water Authority, because they are not elected, they have continuity and historical knowledge. They're able to provide oversight and the management of capital projects that can far exceed the 2 years that a typical town board member sits in this dais. I'm hoping to break that chain. I've been here 2 terms, and so I feel that I've gained a tremendous amount of knowledge since my arrival here, and to the thought that someone would have to start fresh to understand these water and sewer districts, it's frightening because they are very complex. They are take tremendous time and understanding, and so that is one advantage to the Water Authority, that they're not a political organization, so they have that continuity. And then the fourth benefit could be townwide savings, as local government officials are relieved of the increasing complexities of operating and managing small water systems, and thereby able to commit greater time and attention to core municipal functions. So that is, in a nutshell, what we hope as a town can be gained by the transferring of these districts to the Water Authority. During 2014, the town of Hyde Park completed this independent engineering evaluation of the neighborhood water and wastewater systems managed by the town focusing on system condition as well as opportunities to streamline and improve service delivery. Specifically, the grant-funded engineering evaluation has provided the town with an independent assessment of the Pinebrook Estate's water and sewer systems. The results of the evaluation explore the current condition and the need for significant improvements. The town is in agreement with the findings of this report. Based on the engineering evaluation's finding, the town and Dutchess County Water and Wastewater Authority have developed a system management plan and propose to transition ownership and operation of the systems from the town to the DCWWA. So essentially, we acquired your water and sewer districts around 2010, if my understanding is correct, and that was at the request of the Homeowners Association, and there had been numerous issues with the maintenance and non-maintenance of the system, and so the town was asked to be part of that. And that's very typical for how the town got in the water and sewer business. It wasn't exactly our first effort, but really it came about when the residents asked us because of problems with their systems. So we are here, and we have been here, and we've been trying to sort these out and to provide the oversight that's needed to maintain them and to bring them into the future. So with that, I would like to introduce Bridget Barkley, who will give you all additional background and information on the Water Authority. Now, she doesn't need to stand to the side because she's one of the tall people.
Not in comparison to some.
Yeah, we'll soon find out.
So as Aileen said, I'm Bridget Barkley. I'm the Executive Director of the Dutchess County Water and Wastewater Authority. For those of you who don't know us, we are a public benefit corporation. We're not a county department, but an independent entity that was established by the County of Dutchess through state legislation specifically to address water and wastewater issues throughout Dutchess County. We were formed in 1992. We started owning and operating water and wastewater systems in 1995. We are governed by a 5-member board of directors. They are appointed by the county executive and the county legislature, and they are legally responsible for the overall functioning and activity of the authority. We now own around the county 11 water systems, 3 wastewater systems, and 1 water transmission line. Those are spread through 11 different municipalities in the county. We serve a little bit over 4,100 different customer connections through those systems. We have a full-time staff of 20 people. Included within that is management staff, licensed engineer. We have licensed water and wastewater operators that hold the highest water and wastewater licenses that the New York State issues. We have project managers and facilitators such as Jonathan, and we have administrative staff that deals with functions like billing and bookkeeping for our systems in-house. The systems that we own and operate, we run through a combination of either our own employees operating, doing the day-to-day operation of the facilities, and we also use contract operators such as VRI that currently operates these facilities for the town of Hyde Park. Over the time that the authority acquired systems, because with one exception, everything we own and operate was pre-existing, we have done those acquisitions always at the request of the prior owner. In some instances, it's been a municipality, a private company, in 2 instances, homeowners associations that were the prior owners of the systems. And we have been asked in virtually every instance to come in because there were problems with the facility. Some cases it's been financial problems, but by and large it's been infrastructure issues. It's been facilities that are dealing with aging infrastructure, with water quantity or water quality problems, and a need to make substantial upgrades to their facilities. So over the last 20 years that we've owned and operated water systems, we've made about $45 million in capital improvements to those systems. So we have a tremendous amount of experience dealing with systems that have problems like you'll hear about tonight and bringing those up to a better, more reliable standard. The Water and Wastewater Authority, just to follow up on that a little bit more, is a public organization. So our meetings of our board of directors are public. We're subject to freedom of information laws. We work very hard to be accessible and accountable to the people that we serve. We provide information through regular mailings that go out with customer bills. We maintain a website, www.dcwwa.org, where we post current information about all of our systems, budgets, rates, rules, and regulations. We even have a function on that website that will provide an alert to anybody who signs up. So if there's some issue with your system, or even just we're doing a regular flushing program, you can get a notification about that issue for your specific system. So again, we work very hard to be accessible, to be accountable. In many of the systems that we've acquired, there were local customer advisory organizations, advisory committees in place when we took those systems over, and we've continued to work with those groups. I was just telling Wayne earlier, we have one system we took over in 1996, and one of the people who was the chair at the time of their water advisory committee still comes to our board meetings on a monthly basis. So we look to continue that interaction with the customers of the systems that we serve. So it's a little bit about who we are and what we do. And with that, I'm going to turn it over to Aaron, who is going to talk about the results of the engineering evaluation that was done first for your water system.
Hello. Give me one moment to get going here and make sure everyone can hear me. Oh, sorry. Okay, so I'm clearly a New Yorker, but I went to school in Boston, and we happened to go to the Red Sox parade, so that was my kids and my husband at the Red Sox parade, so please don't hold that against me. So again, I'm Erin Moore, and I'm from Ty & Bond Engineering, and I was one of the project leaders. Oh, how are we doing? Okay, good. For the Pinebrook water and wastewater system evaluations. And before I discuss the specific evaluation, I just want to provide you with a quick review of water and wastewater systems, just to make sure we're all on the same page. So the water system for Pinebrook consists of source wells, there's 3, and a water treatment plant, and distribution piping, which carries water to your house that you use for drinking water. The wastewater system consists of collection piping, which takes sanitary sewage from your house, brings it to a treatment plant, it gets treated, and then discharged to a little stream. And it's, actually, that's the water plant down there, red dot, and there's the wastewater plant there shown at the red dot. And I'm sure with the small community, you know where both of these locations are. So there were 4 main steps to the system evaluations. Understanding what's there, what's the existing system, and then understanding what needed improvements there were, what could use some improvement, prioritizing these improvements, what was critical and what was less critical, and then estimating project costs. The items that we reviewed for the water system improvements include system capacity, how much water do you have? Fire flows and the pressures in the line. Do you have sufficient, either of those? The water quality, drinking water quality. The conditions, the physical conditions of the facilities, and if there was any potential for interconnections with another water system. For the wastewater system evaluations, we looked at the capacity of the plant versus how much wastewater is generated from the community. Inflow and infiltration. This means is stormwater getting into your sanitary sewer pipes, and is that a significant problem? the quality of the wastewater effluent, so how clean were we getting it, and then the condition, physical condition of the facility. So to evaluate the physical conditions of the facility, we completed a very, very full day on March 11th of site visits. We saw the water and wastewater facilities in the same day, and it was a lengthy adventure. We looked at the site, just what's there, the driveway, parking, fences, anything like a physical site characteristics, safety components, the actual treatment equipment or mechanical equipment, the physical buildings themselves, the support systems, heating, ventilation, electrical, if there was any fire suppression, instrumentation and gauges, things along those lines. And then also for the wastewater systems, we inspected all the manholes in the system. And then we prioritized, once we identified the needs, we prioritized them. Urgent issues were mainly safety issues or equipment that we felt was about to fail. Short term were things that we thought should be replaced within the next 5 years or just dealt with in the next 5 years. And long term are things that needed to be dealt with in the next 15 years. And then we developed cost for those items. So system costs included sometimes getting equipment quotes, and then estimating how much it would cost to get existing equipment out of the building and then put the new equipment in. And then, if needed, providing temporary services in the interim when that work was going on. Then we applied standard markups to all the costs for contractor overhead, engineering design, costs that would impact the system owner, whoever that may be, and percentage for project contingency, so to account for unknown conditions. These costs are intended to be very conservative, and we looked at the projects as if you did one single thing and you didn't group it together. Also, that you didn't use any in-house staff. You went out to bid and got a contractor for all of these activities. If work's done in-house or there's a group of work done at the same time, there's obviously savings with that. But for budgeting purposes, we need to be conservative because we don't know how these projects would be approached in the future. So that's just how we typically handle this, so you can look at one item and have a cost associated with one single item. So now I'm going to speak specifically about the water system evaluation. So there are 3 source wells. The wells produce between 43 and 50 gallons per minute, which is very sufficient for your residential water needs. But it is not sufficient for fire suppression. So there is not sufficient flow to provide fire suppression from your water mains. The system pressure is acceptable, but there are hydrants that can be used to flush the system, but you don't get a sufficient velocity out of that. So in other words, we'd like to see water moving faster to really clear the lines out, and it's a little low for what we'd prefer to see. The water quality at Pinebrook is generally good. There are a few issues that have popped up. There's high iron and manganese, which is tended to believe from wells 2 and 3. There is high hardness across the board. Hardness is not a health concern, but you know it does things to your pipes and laundry and can make life in general hard, so to speak. So, and then there also is high sodium, which is a concern for those with a very sodium-restricted diet. And so that's more of a public information importance, that if you have folks who are living in Pinebrook that have a sodium-restricted diet, they need to know that the drinking water is going to exacerbate that condition. So there was, iron and manganese do have regulatory limits, and there have been violations for those limits. The other 2 are more guidelines, hardness and sodium, that you'd like to be below, but they're not Department of Health violations by any stretch. If hard water, half of New York would be in violation, right? If that was a regulatory limit. So these are the existing system components. So again, we've got our 3 wells. We've got a treatment building, chlorine disinfection system, a softening system, 2 storage tanks, 2 booster pumps that are used to bring up the pressure, a pressure tank, about just shy of 8,000 feet of 6-inch water main, and 9 flushing hydrants. I just want to note the hydrants. While they're not, because of water capacity, suitable for fire flows, if a situation came where you had more water, they are the right type of hydrants to provide a fire connection. So they do make just these little hydrants that are made for flushing. No, these are, you have real fire hydrants suitable for connections, so. Do we want to do that? Sure.
No, not we do that.
No.
Is the 514 and the hardness before or after treatment?
Oh, that's after. All of those numbers, I'm sorry, are the water quality post-treatment. That's a good question, yeah. Go ahead.
I have to look first. The fire hydrant.
Yes.
All right.
Oh, sorry. I got in trouble.
Used as the steamer connection. In other words, if the pumper has to pump into the hydrant.
Can you just hold on for one? Oh, we've got a problem. Hold on. I'm sorry. There's a voice talking. You need to speak into, that's what's happening.
My question is, the hydrants on the property,
Yes.
if we need to use those hydrants in the case of a fire or a building going up, can the pumper, the fire truck, pump into the steamer connection of the hydrant and use the 2.5 outlets on that fire hydrant without backing up into the pump house?
That's the second part of your question is what while physically that could happen, your neighbors would not be a fan of that. And in general, the fire department is very familiar with what you have there, and in general practices what you call rural firefighting techniques, which is tanker shuttles and bringing water there. Without that level of flow, when you open a hydrant to get a fire flow out of it, immediately everyone is going to have rusty, sediment-filled water in their houses, and again, would probably not be a fan. Also, simply the amount that would come out is just not sustainable, so we'd also run dry very, very quickly. So there wouldn't be a huge amount of value to using the hydrant in that way, pumping in, and that just wouldn't be a huge amount of value. So. All right. That's a questions. So where were we? Okay. In general, both the treatment and distribution system is in good condition. Absolutely. So based on the facility evaluation, we had several recommendations for improvement. First of all, as noted, there's typically only one well that's regularly in use, and the district was issued a violation from the health department because of this. However, it's believed that wells 2 and 3 are the ones that have the high iron and manganese. So because of which is also caused, as we saw, Department of Health violations. So what we recommend is to get all 3 wells flow tested. It doesn't look like that's been done any time in the near past, and really know what each of them are doing. The numbers we've presented were numbers that the Department of Health have on record, but we don't know where they stand. And then sample each well individually to figure out how much iron and manganese is coming from each well source. There are softeners that are on site to be used for, which aid in helping with the iron and manganese problem. So get those running again, and then see where we stand, and to be able to develop a course of action as far as that goes. Now, since we made these recommendations, the water softener has been brought back online, and the iron and manganese in the effluent seems to be good. However, the water softener is going through a lot of salt, which means money. Salt costs something. So still what we'd recommend is get them flow tested, sample each well, look at how much the softener's running, and figure out where to move from there. But already taking this step and getting the softener running means you've got multiple wells running now, which is appeasing Department of Health. That's what they asked for there to be multiple wells. So we're certainly on the right side of Department of Health when it comes to the things that we were cited for, and now proceeding forward. We just got to see how treatment affects and how our salt usage continues. So. So urgent improvements. There were several upgrades we recommended to the chemical feed system that there's disinfection, it's bleach, it's a chemical. You'd like to see a few things for safety. Spill containment, that just means if the tank has a hole, it won't go all over the floor or into a drain. Labeling the tanks, so you know what's in there. An emergency eye wash, and shower installation, and then also a ground fault receptacle for the chemical metering pumps are what we thought were urgent issues. Other urgent improvements include venting the generator outside. The generator is vented in the building, providing a fire extinguisher, and replacing the sample taps. And let's see if I can get this to go on. That's the sample tap right here. So you can see that might not be the most sanitary sampling, and you could have perfectly clean water, but if there's a little bit of gunk here, you could get a fecal coliform, and that we don't want that. We want your water, when you test it, to be true to actually what the water is you're getting. So replacing those sample taps is a good idea. The improvements, significant improvements that we saw coming in the next 5 years include replacement of the booster pumps. Pumps typically have about 15 to 20 year lifespan, and they're certainly there, so it's going to be coming up on the horizon to replace those. The roof definitely is going to need replacement, and there's a few other building maintenance items. Some improvements to site security, and replacement of the electrical system, including the generator. From my understanding, the generator actually is not very powerful. It can almost just run the lights in the building, so it's not going to maintain your water service. So that's something important. We really, maybe a little larger generator that would actually run the treatment process would be a good idea. So recommended improvements for in the next 15 years. So looking out down the road, what we're going to be looking for. Replacement of well pumps 2 and 3. They're getting on in age, so new well pumps are going to be needed eventually. Replacement of the storage tanks. Those also are getting will be at the end of their service life, certainly in another 15 years or so. You saw the sample tap, but there are some areas of the treatment building piping that's looking similar, and we certainly are going to need to be replaced. And then there's a little exhaust fan and unit heater, and those certainly will be at the end of their lifespan by 15 years. So those are our long-term improvements. Oh, and I'm missing the costs. I'm sorry. The total cost that we have estimated for those long-term improvements is $556,600. And I just want to remind you that's the sum of all these individual projects done by an outside contractor in a bid fashion with prevailing wage. So they're certainly budgetary and conservative. So the other thing that we reviewed is the potential for interconnections with other water systems, which would eliminate the water treatment plant at Pinebrook, because you wouldn't need to treat your own water anymore. So these included connection to the Arbors, Greenbush, and the Dutchess County Water and Wastewater Authority Hyde Park system. Connecting to the Hyde Park system is the most feasible and the most cost-effective, but the total estimated cost is $1.2 million, and that's certainly more than all of these improvements combined. So at this point, it's much more efficient to continue to run your own system economically than be looking for water elsewhere. Certainly, if the iron manganese continues to be a headache, then it might be something you want to come back to and look at, but that certainly should take some future analysis. And that concludes our evaluation on the water system. And I'm going to turn it over to Jonathan Churns.
Yeah, come on. I'll work on the microphone. I'm going to do a little height adjustment here. Can you hear me now? So,
Oh, right, yes.
I'll just
Everyone was so great at just asking questions, so I assumed. Sure, go ahead.
how much of your analysis is based on the analysis that was done by Morris Associates when the town took over the water system 5 years ago?
We really looked at it from a new perspective, and we did all independent modeling of the different systems. So while we reviewed all existing documentation, it's a pretty fresh look.
I know 5 years ago when the town took over that Morris Associates did their analysis. They had a laundry list of things, basically like you just came up with, short-term and long-term repairs that need to be accomplished. How much of what they decided needed to be done 5 years ago has been done, and how much still remains to be done?
I'm not familiar with that list off the top of my head, but there's not, the water softeners have been rehabbed recently, but other than that, and I'm just going to say this, there's not much in that building that's less than 5 years old. So, but I know that the water softeners were rehabbed recently.
I remember one of the things they talked about was replacing the primary settling tank at the sewer plant.
Oh, we'll move on to wastewater.
Oh, okay.
Oh, don't worry about that. Oh, yes, please. Wait. I'm going to get beeped again.
You gave a price of roughly $400,000 combined the long-term and short-term. Then it was like $1.2 million for the long-term, for the alternative to hook into the DCWWA. Did you look at the cost as it would be per person, because you would increase the size of the water district and people on Holt Road? Are you going to talk about that, John?
Yeah, if we could hold off on that a few moments, I'll talk about that a little bit more in detail. It's a very good question, and we will address that.
Is that, and I'm not going anywhere, so if anyone thinks of anything, I'll be back. All right.
Good evening. I'm Jonathan Cherns with the Dutchess County Water and Wastewater Authority. I'm a project facilitator, and I've been working with the town of Hyde Park on these projects for several years now. And in the last year, we've had a great effort to understand your systems and move them forward. And we will discuss the sewer district at a later time in this meeting. So the purpose of tonight, one of the purposes, is to bring a lot of this information to you and bring you up to speed on where we are of the understanding of the system. The engineers brought forward their findings and all of the costs that go along with the improvements that they recommend. The Dutchess County Water and Wastewater Authority is an organization that owns and operates water systems, as we've mentioned. And we've looked at your systems, the engineering reports, the findings, and we've organized the information into a holistic approach where we would do some of the work that's been mentioned in-house. We would consider some components would be deferred until a decision could be made on what is the best way to operate the water system. But let me get into the details here. It's always good to mention where the money came from. A good portion of this set of studies was funded by the New York State Department of State through their local government efficiency grant program, and we thank them for their contribution to the project. Within the first 5 years of operating the Pinebrook water system, the Dutchess County Water and Wastewater Authority would seek to do certain improvements, and we would use our in-house staff. We would also use our contract operator that we would carry forward, that's VRI, that the town is currently utilizing to operate the facility. We've organized the improvements that we would be looking to do in this list here, and I'm going to go through some of them. We'll highlight a couple of them, and then I have another set of slides where we'll talk about items that are deferred and then why we would propose to defer them. So obviously we have a lot of chemicals in the facility, and so you need to have worker safety as an important component, and having an eye wash station in the facility is important. We'd look to move that forward. The generator, as Aaron was mentioning, is undersized at this time. It really only runs one of two booster pumps. It provides pressure to your system from available storage, but it does not have the capacity to run your pumps, chlorinate the system. Many of the components in the facility are not available. You cannot obviously run the water softeners that we've discussed a couple of times. So the generator is undersized. but it meets your needs to provide pressure to the system and provide the water that you have during the initial part of an emergency. You're shaking your head. Is that a no?
It does not.
It does not. The answer was it does not. Well, so we recognize.
In practical terms, it does not have the power to provide water to the system in the event of a power outage.
So what the answer was from the gentleman in the audience was that the generator does not have the capability to provide the power to run the facility and provide the service. We recognize that and understand that the generator would need to be replaced at some point in the near term. In the next slide, I talk to that a little bit more. But in the immediate need, it does provide some pressure to the system and keeps you operating through a power outage. And so at the minimum, we would look to vent the generator to the outside so that it is no longer an issue to the facility and those operating it. And we'll talk a little bit more about the generator as we go on. Simple things like fire extinguishers, the hydropneumatic tank. In one of the photos that you saw up there, it is protrudes from the wall of the water plant, and the paint is peeling off, it is rusted, it needs to be scratched and painted so that it can be preserved for as long as we can use it to improve the lifespan. Security for the wells needs to be improved. Grading around some of the wells should be done to ensure that we don't have intrusion of water into those areas inappropriately. Surge protection for the wells should be installed. Certain vents and manways need to be secured so that we don't have issues with people getting into the facility that shouldn't be there. Generator signage, hearing protection, more worker safety items, protecting the envelope of the building. So the building is approximately 30 years old. It was built in 1995-ish, and the roof, the gutters, certain eaves need to be updated, and so we would look to do that in the first 5 years. More painting on the inside, and then obviously GFI receptacles are important when you're working in a wet environment to make sure that your workers are safe. And so there are certain points in the facility that we would look to do that. The total estimated expense for this is $65,000. We would move this forward through fund balance as well as from the revenue of the system to make these improvements. And these would all be done in the first 5 years. Looking forward and beyond the urgent items that need to be done for worker safety and just to generally keep your plant operating, there are more long-term concerns about what needs to be done there. The iron and manganese is obviously an issue with the facility. There are drinkability issues that come along with the sodium and so on, and those are items that can somewhat be abated through the treatment that you have at the site, but may require a future look as those wells maybe change over time. As Aaron was mentioning, there needs to be more understanding of what those wells can produce and how they're changing over time. So in comparison, you have these unknowns that come along with your water treatment plant. It is probably the low-cost option to continue operating that facility and move it forward. As an alternative, though, there's the interconnection with the Hyde Park Regional Water System, which would bring fire protection to your area, as well as different pressures, probably better. All that would need to be determined through an engineering evaluation. But there are opportunities that in the future that could happen. $1.2 million and how that would divide across your community is probably a difficult number to reach economically with just your community. If you can remember back to the slide that Aaron had up there, there's the Holt Road area that runs by your community, and there's an opportunity that area could have water service at the same time. By adding more customers to that area, we'd be able to spread the capital cost across more users, thereby making it less expensive per dwelling. And ultimately, that would be one opportunity. How that number divides today, we don't know, because we don't know what intermediate areas would want to interconnect. There's also the opportunity that Greenbush and Violet Avenue, which currently have water quality issues from the water that they purchased from Poughkeepsie, may also want to interconnect and could further spread the cost and make it more economically viable to receive water service in your area. So there are certain items we're about to talk about in the next slide that we would recommend be deferred for several years while we evaluate this situation and understand what it is that you have with your particular water plant. So again, there's that future decision point of how do you move forward? Do you interconnect with another system or do you maintain your system? If at some future date it's decided that an interconnection is not the way to go, these items will need to be addressed. And so there's the generator. It does not run your facility, it does not meet your needs, and so it would need to be replaced. That's not an insignificant cost, but it is one that would need to be addressed. The electrical systems within the facility are approximately 30 years old, and they are reaching the end of their life cycle. As we get in beyond 5 years, you're at 35 years. You get beyond 10 years, you're at 40 years. Again, these things need to be addressed. The booster pumps, they are at or beyond their lifespan and need to be considered for replacement. And I think there was a photo of them in the earlier slide, and it showed that they, and some components are actually somewhat rusty, which gives you a window onto the condition of the equipment throughout. Flow testing the wells. We've talked about that a couple of times here. Basically, wells draw water from the ground, and there's screens in there, and over time they get clogged. The ground can change its ability to draw the water. The chemistry can change depending on how much you're drawing. And the flow tests with the chemistry that go with it will give you a window onto what is the life expectancy of the wells that you currently have and how you move them forward. And then well monitoring instrumentation. If you have data over time, you understand better what it is that your wells can produce and how you would carry them forward. So these are all items that we would look to address in the long term if you don't seek to interconnect with the Hyde Park Regional Water System, and the Water Authority would carry your plant forward as it is and try to make the best of the wells that you have with the chemistry. The total expense for these items we predict would be about 180. This is using our in-house staff as well as our contract operators, and some components may have to be done through other processes because they're larger expenses. And next, I would like to invite Bridget up to speak to the financial evaluation of your water system and how the Water Authority would operate it going forward.
So the other part of the overall evaluation, along with looking at the physical condition, is to look at the financial condition of the facility. We looked at actual revenues and expenses over the past several years. We looked at the projected results for 2014 and what the town has recently adopted as the budget for 2015 to determine the overall financial condition of the facility, and so that we could present accurate projections of what those costs would be under the authority's ownership and management, and ultimately what that translates to you as a cost per household. So starting with your current rates, you pay a usage rate for your water, an O&M charge that's made up of a quarterly charge of $40 per quarter for $160 a year, and then a metered usage charge of $5.25 per thousand. For the average water customer in Pinebrook, that comes out to a charge of about $210 for your metered usage and a total cost of about $370 a year. So you are well below the statewide average threshold that the New York State Comptroller provides each year of $862 a year. So from that perspective, you're in good shape. I think it jumped a few. Okay, yep, that's what I wanted. So here's a presentation that we put together of a multi-year budget evaluation for Pinebrook. Again, as you can see, from 2011 through the 2015 adopted budget. A couple things specifically to note is that over time, overall expenses are trending upwards. Electric, obviously, you know, from your own household electric bills, electric rates have been increasing. There's been some increasing expenditures for equipment repair and maintenance that you would expect with a system of this age. One of the initiatives of this administration and the town has been to look more carefully at the cost of the labor that the town provides to administer these systems, to deal with the budgeting, the accounting, the bookkeeping. And the town has been working to increase those numbers to accurately reflect the cost of the labor that the town provides to the system. So you do have generally upward trending expenses. Rates have remained flat since 2010 when the town took over the system. The system has a healthy amount of fund balance. We show each year where the fund balance amount starts and where it ends. And as you can see, you were really building fund balance over the last couple years, but in 2014, expect to use some of that fund balance to offset system expenses without impacting rates. And again, projecting to use some fund balance in 2015 as well. We generally like to see about a 20% of your operating budget held as a reserve, as a contingency in the fund balance to help meet cash flow needs, to help meet any unanticipated expenses. And certainly this system has more than that amount in the fund balance, but you also want to look again at that dollar amount against what the identified urgent and short-term improvement needs are for the system as well. So the next thing we did was put together, for comparison purposes, a 2015 budget if the authority owned and operated the system for the full year. And the way that we approach the management of the system, the operation, the billing, and the bookkeeping, and so on, all of which we would do in-house. So the bottom line is that we see the expenses being very similar to the expenses that the town has budgeted for 2015. We would see the current rate structure that's in place being suitable and appropriate for the system, in particular given the fund balance that the system has. So at the end of the day, the bottom line is if the authority were operating the system in 2015, we would see no impact on the customer rates. Over time, as systems age, as you do deal with more infrastructure that needs to be replaced, as the fund balance that you've accumulated gradually is drawn down, over time you would need to see a gradual increase in rates, whether it was owned by the authority or the town. But overall, for now, we see it as a system that's in good shape financially, where the rate structure is appropriate. So I think what we talk about next is, again, whether there's any questions that anybody has, and then we're going to go on to a discussion of your wastewater treatment plant. So any questions on anything that we've covered so far? Okay. I'm going to turn it over to Jonathan. He's going to give a little bit of a quick history just to help put in context some of the discussion about the wastewater plant, what some of its particular history has been.
Thank you, Bridget. A quick history of your sewage treatment plant. This somewhat also lines up with your water treatment plant, but it has more parallels for the sewage treatment plant. Maybe in comparison, it would be good to talk about both for a moment. Your water treatment plant is a concrete block-built structure. It's in relatively good condition and for its age compared to the sewage treatment plant. Your sewage treatment plant was originally developed by a developer. It was put in as a steel package plant with no protective coatings. That was done about 1985. Eventually, the developer abandoned the project before finishing all of the homes, as some of you may know as longtime residents. The Homeowners Association then took the opportunity to run the facility as a necessity and carried it forward. A new developer eventually came in 2001, finished out the homes, and moved the project forward, finishing the collection and distribution system and so on. In 2010, the Homeowners Association, the developer, asked the town to come in and take over the system, and so the sewer district was formed and the system was eventually transferred. There's a document that was created in that transfer process called a map planner report, and that contains the everything you need to know about how the system will be transferred, the improvements that need to be done, the cost to the customers in their first year, how capital improvements at some point would be apportioned among the customer base, lays out the properties that are included in the boundary and so on. And when you read through that document for the sewage treatment plant, you see that there were significant components that were identified in 2010 by the town that would need to be addressed. And as Erin goes through her engineering evaluation of the system, she'll highlight some of those components and lead you through that just to show you where you're at today. But just to mention to start, the influent tank where everything comes to the plant, as well as the equalization tank, that one that you see outside with the lattice fencing on it, those were identified, as well as the sludge holding tank, which is a part of the EQ tank, as needing to be replaced in the first 3 to 5 years of the town's ownership. And so what we found, and Erin will go further into this, is that many of the tanks, because preventative maintenance and also the protective coatings from the early days of the operation of the system were not done. We're finding now at 30 years that all of the tanks are in a similar condition to what was found with the influent gallery, as well as the equalization and the sludge holding tank. And so that's your history of your facility and how we got to where we are today. But remember that there are many actors along the way that have led to this facility reaching this particular state. I'd like to ask Erin to come up.
Oh no, they're back. That's Preston Josephine. So as Jonathan explained, I'm going to move on to the wastewater system evaluation. So the plant has a capacity of 48,400 gallons per day, which is very sufficient to meet the needs of Pinebrook. Average flow about 16,500 gallons per day. We inspected the collection system for signs of inflow and infiltration. I mentioned that earlier, that signs stormwater's getting into the system. And while we found some evidence of that, it wasn't a big significant impact. Sometimes stormwater can be the bane of a sewer system and really get into the collection system and triple flows or quadruple flows. And that's not the case at Pinebrook. So we reviewed the quality of the treated wastewater effluent. And there were several effluent violations in 2012 to 2014. And violations are a serious issue. Through the combined efforts of the town, their engineer, Morris Associates, the plant operators, VRI, and with operational management provided by Dutchess County Water and Wastewater Authority, some temporary patches were put in place to improve the plant, and no violations have occurred since this last one in March 2014. So everyone really rallied and came together to stop the violations, which certainly can lead to DEC action, and none of us, we don't want that. That'd be a problem. So everyone really came together like a super team to get the plant back on track for now. So the physical components of the wastewater system: about 3,000 feet of 8-inch sewer, 13 manholes, an influent pump station, and it's called a rotating biological contactor treatment system. So in general, the collection system, we found it was in good condition. And the treatment system, we found it was in very poor condition. So we categorize the treatment system as poor for several reasons. Most components in the treatment plant, installed in 1985, they've reached their service life, and most of them are beyond, and many of them were not functioning as intended. The atmosphere in the building is very humid, there's no ventilation, and it was deteriorating equipment even further that still was functioning. It's really has some problems with rust and just in general deteriorating. There were many, many safety concerns. Not the least is the physical condition of the building. It was very deteriorated. The lack of ventilation also damaged the electrical components. So as I noted previously, as far as urgent improvements, we were really concerned about safety at the treatment plant. Significant concerns included egress or lack of egress, which is certainly a concern for operators. Lack of railings, damaged ceiling panels that were falling down. That's certainly a hazard. Exposed roof trusses, which showed signs of significant water damage. And electrical panels that were in poor condition. There's also very limited site security, and I know there's been a little bit of a recent improvement on that, and there's an open tank right in front of the building, but pretty much no stop to access. And I'll tell you a quick story on this. We had surveyors who were part of our team who went out and did some manhole inspections, and they said, oh, we had to walk up to the building and look in the tank. And they're surveyors and who see wastewater stuff all the time, and they could not abate their curiosity and go peek in the wastewater tank. So if you extrapolate that, I mean, probably when I was a kid, I would have looked in the wastewater tank, but it certainly is a little bit of an attractive nuisance if there's no protection. So we understand definitely that some of these items have been, had some temporary fix to resolve some of the most critical safety concerns. Definitely one of the things that we wanted to emphasize is ongoing checks on those roof trusses, because there was a lot of water damage there. And I'm going to quickly try to show some of this. So there's, you can see staining right here, but actually March 11th last year, a lot of snow on the ground. There was still snow on the roof. And this little bit here is actually droplets pouring down onto where these trusses come together when we were actively in the building. So we're quite concerned about that. So I understand this tank looks a little bit, there's been a little bit of more safety put onto it, but this is just welded wire. And again, there's not much stopping you from getting in here. Here is the building itself. These are these RBCs we were talking about. At the time we were in here, this is a piece of plywood that says open hole. And here are our electrical panels. That shouldn't look like that. Okay. So we did have a few recommendations for the collection system. Again, in general, it was very good, but there were some manholes that had a bit of infiltration we'd like to see sealed up. So this, if you could see this, this is a manhole that's got that melting snow, and so there's pooling water on top, and anytime that happens, that's introducing water into your collection system. Why don't we want that? Because you have to pay to treat the water. So why would you want to treat clean water? You don't. So you want to keep storm water out of your wastewater system. And here, this is the manhole outside the plant, and you sort of see that staining on the wall. So there's some leakage going on there. So short term, seal the manholes where we noticed a little bit of leakage coming in. And then in front of the rec center, we've got this trouble section of pipe. We don't know what's going on there. It should be TV inspected. See if there's a belly in it, it's sagged. What's happening in that piece of pipe, because we know that section has had some trouble in the past. Then for long-term system improvements, just we recommend sealing up the additional manholes, prevent future deterioration or groundwater getting in, and we put in funds to replace that section. Now, until you TV inspect it, we don't know if that's what's going to fix that, but we need to see. So we definitely have the funds in there to replace that section in front of the rec center from manhole to manhole. And so that's what the budgetary number we put in for our long-term improvements. Okay, and so I think you know where this is all going. For the treatment plant, we have recommend complete replacement. And there are many reasons that go into that recommendation. Some of the components don't meet current standards for their sizing. Clarifiers, the sand filters, the contact tanks, and also the steel tanks they're in a very deteriorated condition. They're at the end of their life, and there's not much we can do with this. You can temporarily fix them, but you can't weld rust, and that's really the condition of these tanks. A failing tank could mean an immediate release to the environment, and and everything's in steel tanks. So there's just not a lot of approaches here in regard to fixing these steel tanks. It's expensive to fix them, and they're going to just continue to fail. The other point is the structure. We're very concerned about the structure. The structure needs to be replaced. So this is a good image. If anyone, I'm sure it could be arranged, has not seen the plant and has an opportunity to see it, you really should. The big tank out in front, though, is a great place to look at it because it's bright, it's daylight, you can see the tank, and all the tanks were the same material and installed around the same time. So the condition of that tank can help you gauge what the rest of the tanks in the plant you're going to encounter, certainly at the water level or beneath. So this is showing some of the level of corrosion and rust in the tank. These, again, are the RBC units. You can see the ceiling panels, some that are down over the units themselves, but things just hanging down there. It's also so tight in this building. And you need to be able to get around equipment to operate it. And here, you know, there's even places where I sort of had to do the side shuffle to get around. And that's not what you want for your operators. And here's that tank I was talking about. We can see that you can see that pretty easily from the road. What's the cost here? $3.4 million. That's a high cost. That's a really high cost. However, we are discharging to a stream, and it's not a big stream, it's a little stream. And what that means is you have much stricter discharge requirements than if you were going subsurfacely or going to the Hudson River. Because of the size of the stream, you have to treat to a pretty high quality, and that means additional components. Also, we have not a huge site to work with. So it's not like we have acres of area to sort of spread out and do something maybe bigger and cheaper. We have a tiny footprint and I have to work within that. I don't know, I have my eye set on the rec center. Maybe we work at the rec center and then move the rec center, I don't know. But that's the kind of creativity that's gonna come into play. You got wetlands behind this site, the slope drops off. So there is not an open canvas, let's say, to work with, and that amps up the challenges here to really figure out how to get a new system in, how to keep your old system operating when it goes in. And so all that adds to cost. Again, we've tried to be conservative and budgetary, but that's the number we feel comfortable putting on here.
Would you be replacing it with a package plant type, same thing?
You get a few options, and definitely, yeah, I'll talk a little bit about that. There's several things that would work. So, yes, in general, it would be some type of package plant. No steel tanks. Yes.
How much time do we have here before the roof falls in and the thing, and we have an environmental disaster?
Exactly. Time is the most critical factor here. As Jonathan noted, it was generally agreed in 2010 that major things needed to happen at the plant. And now we're 5 years later, and none of those things have happened. So as the years go on, the plant's in worse shape, and this is nothing that we can just click our heels and have a brand new plant. This is what would happen. Let's just say, starting today. The first thing you need to do, that was a good question about the package plant. We've got site constraints, what's gonna work? So we've based our costs on putting a new RBC plant in because that seemed to be the most reasonable approach. The operators are very familiar with it. But there's some other technologies that have a smaller footprint but are a little more expensive. A preliminary design study figuring out what's the best technology, first step. Then that design study is used as a basis for design where drawings and specs are prepared, and it goes out to bid and it's built. And that does not happen overnight. So our time is ticking now because there could be a critical failure. And what's it mean? It means money. Because at the worst case scenario, there literally are wastewater treatment plants that can show up on trailers, and they are very expensive to rent by the day. And so that's the main goal here is Let's get on a path forward. Also, if the DEC comes into the plant, if you are on a path, their attitude is much different than if you are in ostrich mode. They say, oh, okay, they know, they have a path, they've either commissioned their design report, they're working, we can see the pattern. Their attitude is much different than if it's, you know, la, la, la. So that's something certainly to keep in mind, but yet definitely we're at the point where time is of the essence and a path forward we need to figure out. So looking at an alternate path forward, so we did review the potential for connecting Pinebrook to the town of Poughkeepsie wastewater system. While the capital costs for the, so this would involve a pump station, replacing the pump station that's at the plant, and then force main, a lot of force main, 7,500 foot of 6-inch force main, all the way down. So there's where our pump station would be, all the way down to here, which is where you'd connect to the system. So $2.3 million. We're working around the state road. There's some complexity here. However, that's just to build the pump station and the force main. Now we introduce the town of Poughkeepsie to this equation. And that takes negotiation as far as the municipal interconnection fee. When you take some of their plant capacity, that's a fee. And then how much would they charge the users? That's a fee. And until those items are, and then also, we might need to improve something at their plant. From here, there's actually another pump station to take it. We might need to improve that pump station. That's more cost. So 2.3 is not the final number, and definitely we're recommending progressing to understand these numbers to see what that total ends up with. But time is of the essence. So the treatment plant's going to continue to degrade. And I've been involved in this before, and it doesn't matter what municipalities. Any two municipalities, you get them together to discuss an intermunicipal agreement, it can be a lengthy process. And so as we've moved forward, if it starts to become an onerous task, regardless of what this number becomes, I think that's a question, you know, for the residents and for the owners on which path do we want to follow if you start to see your time really starting to extend. But this is certainly a valuable alternative worth investigating. And so that concludes my presentation. I definitely would be happy to take any questions at this point.
So it's either connect with Poughkeepsie or build our own.
That's it.
That's it.
Wasn't there some heavy costs? I think it was Greenbush looked into the water system, or somebody did with the city of Poughkeepsie, and they charged them a lot of money.
You know, the one difference between water and wastewater is with water, it's the joint board, which is the city and the town, and with the wastewater, we're just dealing with the town, which seems, and they, obviously, we don't put this up here without having at least an initial approach, and they have been approached, they're open to the idea, but that's as far as we've gotten. So they're certainly interested. They'd like your wastewater. If you don't want it, someone else, but it's, you know, not for free, so. Okay, great, thank you so much. Yeah. Okay, I can't promise what's going to be up here this time. Oh, they're back, okay. Do you have pets we can see? Oh, they could come next, I could find that. A wiener dog.
I just want the opportunity to use the laser for a moment here. So again, we're talking about the Pinebrook Sewer District, and we have put together a reorganization study and plan that basically takes you from where you are today to transferring the system under the Water Authority and how we would move it forward. And thank you again to the state for contributing funds. When we look at your sewage treatment plant, obviously there are alternatives that are long-term that have to do with, you know, basically replacing the treatment capacity that you have there, whether it be a transmission main to Poughkeepsie or a replacement of your plant on site. these are things that the Water Authority would look forward to understanding in the future and finding that pathway forward. What's the right solution economically as well as the right technical solution for that. But in the immediate need, there are certain things that need to be addressed. And when the Water Authority went through and looked at what the engineer had put forward, we tried to come up with a holistic approach to come up with an outcome-based solution for your sewage treatment plant. There's a lot of items that need to be addressed, but we've tried to first understand what the town has already addressed, but then also what still needs to be done. And so in the first 5 years, we would be looking to ensure that there's worker safety protection by having eye wash stations installed. There are certain walkways over equipment that are failing and are a fall risk. If you were to look at some of the photos when you came in, you'll see that there's one where a gentleman is actually trying to step over failed walkways to reach to a control panel with a blower which is hanging over the EQ or equalization tank. So there's things down below that you don't want to fall into, and the walkway is not necessarily safe for him to go out there. So we'd look to replace and repair or remove walkways and come up with alternative ways for the operators to get to where they need to be. The electrical panels, if you were to look at some of the photos that are on the wall, as well as the ones that Aaron has shown, the electrical panels are rusted out on the outside, and the inside is in a similar condition, and that creates a operability issue as well as a worker safety component. And so, those need to be replaced in the short term in the next 5 years. The building ceiling, Aaron had mentioned that it is falling down in certain sections. The humidity within the facility, the rain that occurs from just the humidity inside is an issue, as well as during the winter when the snow begins to build up, the roof is not able to keep the water out, and so it falls through. And so if you were to go in the facility and it's raining inside, I recommend that you wear a hat. The ventilation equipment. So there are certain components that are within the facility that need to be protected in the short term. If we're going to do things like repairing the electrical control panels, if there's anything that needs to be done with the generator, the other instrumentation that's on the wall, it all needs to be protected. And so what we would recommend to do here is build an interior wall that surrounds these components with a ceiling, and then provide ventilation, heat, and lighting in that space. And that would protect whatever improvements are made, as well as hopefully extend the lifespan of the components that already exist within that space. And this would make it so we have a separate atmosphere, if you will, from the treatment area where you see the rotating biological contactors, the sand filters, the clarifiers, and so on. The totality of these urgent improvements comes to a total estimated expense of $50,000. And we would look to do some of these immediately, but definitely within the first 5 years to move the facility forward and keep it operating during that period where we're understanding that long-term goal of replacing the treatment capacity, whether that be transmitting the materials down to Poughkeepsie or replacing the sewage treatment plant. And now I'd like to invite Bridget up to speak to the financial components of the sewage plant.
So again, like with the water system, we also look to understand the financial condition of the sewer district, starting with your rates. Flat rate, everybody pays the same amount, $133 a quarter, $532 a year. As a basis of comparison, again, with that state comptroller's average threshold throughout the state of $709, you're not in bad shape as far as the current cost. We looked at the multi-year budget evaluation, and again, you're seeing increasing expenses, as you would expect, electric costs going up. There's been some very high expenses for equipment repair and maintenance because of the aging of the infrastructure and the fact that it's at the point where a lot of the work ends up having to be done as emergency repair work, which always adds to the cost. So again, overall, you are seeing some increasing expenses in the system. The revenues have remained flat. The rate has remained flat since 2010 when the town created the sewer district. And so as a result of that, while the system in a couple years did develop, did accumulate some significant amount of fund balance, there was an unidentified $20,000 revenue from other sources under the prior administration that contributed to that fund balance. There was really a very unrealistically low and unsustainably low amount of expenditures to operate and manage the facility in the past. So since the beginning of 2013, you're seeing that fund balance drop from 140,000 down to 80,000, mostly because of that. And continued use of fund balance to cover the expenses of the system without impacting the rate. You're looking at probably about 60,000 in fund balance, 50,000 in fund balance at the end of 2015. Not an amount of fund balance that we would consider sufficient given the condition of the facility, the potential need to be doing more unanticipated repair work over the next couple years until a solution is developed, and then the known urgent improvement items simply to keep the plant operating of about $50,000. So you can see we're talking $50,000 of known expenses against $50,000 of fund balance. As far as the base budget for the operation, electric, lab, and so on, again, we don't see the expenses being significantly different than what has been budgeted by the town. We know from experience, because we did help work with the town and with VRI over the last 6 months of 2014 to help operate the facility and try to get some of the treatment issues in hand. You know, we think that we have a good handle on what the operation is going to require over the next couple years. We would work very hard to manage it to limit the emergency repairs that have to be done. So as far as just day-to-day maintenance of the facility, you know, we think, or operation, I should say, we think that this is a legitimate budget, but taking into account that you're going to be spending down your fund balance to deal with those urgent improvements that have been identified. So based on that, while we're not seeing the expenses being significantly different, we would recommend, if the authority ran this plant, and we would recommend the same to the town, that you reserve the fund balance that you've got to deal with keeping the facility operating, as opposed to using it to offset an increase in the rates. If you do that with the expenses that are budgeted, the end result is what you'd be looking at is an increase in the rate from about $530 a year to about $590 a year. It's a $60 increase. It comes out to $5 a month. Frankly, the alternative is that the plant deteriorates further. You spend more money on emergency repairs, and you potentially get into those worst-case scenarios that Aaron referenced of having enforcement issues with DEC, having a total failure issue with the plant, and having to bring in a much more expensive solution on an emergency basis. So that's our recommendation as far as where we would see the rates for the system going. Obviously, as you start to deal with the bigger issue of replacement of the plant, whether it is a new plant built on this site or an interconnection with Poughkeepsie, that capital cost is going to have a significant impact on the user charges. We would look to evaluate those solutions not just on what the capital cost is, but what the operational expense is, and essentially you look at it as a life cycle cost. If you implemented one of those different solutions, how much is it going to cost you to build that, to operate it? What's the cycle of replacement of that infrastructure, so that you're looking at the most economical way possible to have adequate treatment of your wastewater. The authority also looks to pursue grant money, low-interest loan money to offset the cost of capital improvements. We've been successful in obtaining low-interest loans for a number of projects that we've done with our facilities. By working with the town, even as the engineering evaluation was being completed, we were able to get the Pinebrook Sewer on what's called the annual list for the state's Clean Water Revolving Loan Fund program. It's the major funding program that New York State has for, in this case, wastewater treatment issues. It's administered by a state agency, the Environmental Facilities Corporation. And essentially what they do is provide low-interest loans. They provide subsidized loans, so the interest rate you're paying on any money you borrow to do a capital improvement is decreased. Under some circumstances, that program can provide all the way down to 0% loan based on a hardship case. Hardship is evaluated on the median household income of the community that's being served versus what the cost, total annual cost per household for the treatment would be, and that would include the capital cost and the O&M cost. We have worked with that program as well before. We've worked with communities to develop income surveys. If we think that the census data isn't really going to give you the best shot at qualifying for that kind of money. So that's going to be an important part of that process going forward. You know, I think everybody can recognize that a $3+ million improvement spread over 132 households is a major financial impact. So it's going to be a matter of not only looking at what is the best long-term solution, it's a matter of managing that project as efficiently and as aggressively as possible to make sure every dollar that's spent is spent wisely. And it's going to be a matter of looking to see where there is outside funding support that's going to help offset that impact. So again, the urgent improvements we see being paid for with the fund balance, but recognizing that that is pretty much going to deplete the fund balance. And then we look for the best way to develop and finance the long-term improvements for the system. And I think that's pretty much the end of our collective presentation. So if there's questions for Aaron, for Jonathan, Aileen, anybody, any questions, we're all here.
And the alternative, excuse me, the alternative to replace the system is $3.1 million. Does that include it at different footprints in order to keep one operating while the other one's being built, or how do you plan on, is that in the estimate?
That's the challenging part.
Yes, I had to decide how many pictures to put in here, but in the report itself, we have a few layouts that would work. I told you I was eyeballing the rec center, but really, I guess that's not off the table in my opinion, but there is a pretty good area behind the plant, but then it starts to slope off. So you could actually do a little bit of filling and retaining wall before you get involved in the wetland, which comes next. I think enough to create an area for a treatment plant. So you would build behind the existing one, could build your plant there, keep the existing one going, and then connect the one behind the plant. And all of that cost is included in that money. Wait, Jonathan, is that regard to that? Oh, yes, and decommissioning of the plant so Jonathan's question was, is decommissioning included? Yes, so that number includes getting rid of the old plant, making that complete demolition of what's there once a new plant would be operating is also in that.
I would assume the cost would be prohibitive to have a temporary system in there, knock it down and put the other one where that one is, and just run it on a rented one.
Yeah, we'd like to avoid, I think you'd like to avoid that.
You had said at the beginning of your presentation the capacity of the plant was 48,000 gallons, but we only use about 16,000 gallons. Is that 3.4 million to build a new 50,000 gallon treatment plant or a new 25,000 gallon treatment plant?
For the estimate, we kept with replacement of the plant, but I think that's a really important consideration. And something that's got to be addressed in design. Often, there's standards of water production, wastewater production, which is like 110 gallons per bedroom. And often, DEC, regardless of knowing how much water that you produce, will want to see a plant designed for that level of 110 per bedroom. However, we've got good water records. We know how much wastewater Pinebrook produces, so I think there's a good argument for suggesting something less than that. You always want to be at least 80% or lower, so you'd never design it for 16,000. And you do see a little bit of stormwater get into your system, but you're completely built out. I think there'd be a good argument to be made for downsizing the plant a bit. So, but it's always a negotiation. That's their typical. They like to see things built for that standard of per bedroom use, and it's sometimes can be difficult depending on what you're discussing.
As a follow-up to that, if you did build it for 50 or more thousand gallons of treatment, is there other areas nearby that might be interested in connecting into it that you could expand the wastewater district to cover those expenses?
Got an opinion on that?
So part of it, you kind of end up in a catch-22, because if you told DEC that, oh, by the way, we're going to add 30 more houses, they're going to say, okay, 110 gallons per bedroom for each of those 30 houses, and, you're back to increasing the size. Looking at it quickly at the area, the density, I think you would have a very hard time convincing any of the properties close by to connect into the system. You don't want to have to spend a whole lot more money on piping, and as you get further away and less dense development, those costs go up per household you'd bring in. So, it's certainly something that can be looked out further, but we don't think that it holds a lot of promise for you.
Fairly subtle point, but one of the town can only borrow for 20 years, and the water authority can borrow for 30. Is that not true?
Based on the life expectancy of the equipment. So we think that in this instance that the town probably could borrow the funds for 30 years. So I think between the cost to borrow the money for the town and the authority, I don't think would be significantly different.
Oh, well, I was wrong on that. The advantage to borrowing longer, of course, is that it brings your bottom line down. So that's what we would be looking to do, whether it would be the town or the authority going forward to make this improvement. I don't really have a lot to say, except thank you very much for that very thorough presentation. Just my impression on managing a project of this intensity and size, it's kind of daunting for a town to take that on. It's a major undertaking, this type of capital improvement, and I think the advantage to having the water authority in that position is very important, not to be overlooked.
Aileen, on the, what's the next steps then? Is there public hearings?
Yeah,
And
I think, Bridget, could you go over that?
So we really weren't entirely done. The next steps with this process, we referenced the reorganization and study plan or dissolution plan that encompasses all of the information that we've talked about. That gets finalized after any feedback we get through these meetings that we're having with each of the customer groups. The town adopts that proposed plan. They are required by New York State law to hold an official public hearing on that, so that would be before the town board. And then the town makes a decision. The town board decides if they want to go ahead with the transfer to the authority. They can make that decision independently for each and every system, each and every district. If the town decides they want to go forward, or for those districts that the town wants to go forward, we then start a process with the county to create a district or zone of assessment at the county level. Functions the same as the municipal district at the town level. What it does is it delineates, these are the properties that have the ability to receive service from the infrastructure and over whom the costs of that infrastructure are spread. That is done by the county legislature, so there's a public hearing before the county legislature, and then they act to create a zone of assessment or district at the county level. At that point, we would then be in a position to go through the process of transferring the property from the town over to the authority, transfer of the real property, any easements, and the ownership of all the infrastructure, and then at that point, the authority would be your new provider of water and wastewater services. So that could happen through the July to October timeframe. Will tell you that we have continued to work with the town on the Pinebrook sewer issue in particular. As I mentioned, we worked to get an application into the state funding program. Everybody recognizes that the time was of the essence to get that new solution on the wastewater. So even as this process unfolds, people are continuing to work towards that goal. It's really not something that anybody's going to be in a position to fund major work until the ownership of the system is resolved. So we would try to move through this process as quickly as possible if that's the direction the town wants to go in.
Just as a little history, back in 2010, the only reason the town took over this water system was because the county bailed out at the last second.
We didn't bail out at the last second. We were not.
Commitment to take over the plant
Yep.
in 2010.
Yep.
So the town took it over.
Yep.
Is there a possibility or a chance that that might happen again on the county level, where the county gets so far into the process and then decides not to go through with it for whatever reason? Where does that leave us all?
So the only, I would agree with you 100%, except that we didn't bail last minute. It was a non-starter from the word go, not by the choice of the Water and Wastewater Authority. Because we have to go through that process with the county legislature of creating the district or the zone of assessment, that's why the county, under a prior administration, under a different legislature, was able to say no. I see absolutely no likelihood of that happening again. The dynamics are completely different. The politics are completely different. The current county executive is probably his single greatest priority is cooperation among, government entities within Dutchess County for the benefit of the taxpayers. So the likelihood of that kind of political unfortunate occurrence again, I really do think is virtually nil.
In preparation for an eventual emergency that may be coming on, where we may have to go either hook up to the town or do a separate plant, I assume there's going to have to be engineering studies being done concurrently. I don't see that 100,000 plus cost being accounted for.
Right. So the cost of doing the engineering for the long-term solution is included in the numbers that Aaron gave. Whether it's the 3.4 million for a new plan or the 2.3 million for capital improvement to connect to Poughkeepsie, those numbers include the engineering numbers. The way the authority would generally approach a project like this is we do what's called a bond anticipation note. You borrow money for the short term, usually a year. And you use that money, you borrow just enough to do your engineering, We're probably looking, you know, 350,000, 400,000 for the initial engineering and site investigations, permitting part of this process. So we would borrow that much for a year. During that time, you'd pay only the interest on that money. And then when the design is done, you've got a much better estimate of what your construction cost is going to be. You borrow the long-term money for that construction cost and roll the short-term borrowing into that. So I believe we looked at the numbers that the interest on a one-year borrowing of $400,000 comes down to about $40 per household. So that would be the first impact that you'd see of the cost of the long-term solution.
Wouldn't you be doing preliminary engineering? If that system failed tomorrow, by the time you get the money for the engineering, do the engineering, and then do the construction, it could be a year and a half from now.
Right, right. It is unfortunately not yep. The problem, frankly, is that the system doesn't have the funding. You know, what's most important, we think, with the fund balance is to deal with those immediate safety issues, to deal with the things that are needed to make sure the plant can operate tomorrow. But yeah, you're right. I mean, the sooner that the engineering can get started, the better. It's the challenge of coming up with the funding to do that.
Height adjustment here. Over the last 6 months, where the Water Authority, and before that even, the Water Authority working with VRI and the town engineer and the town, we've sought to address certain emergency issues that have occurred over the last couple of months and year. The influent gallery, where the pumps are, was causing emergency issues where they were clogging. Originally, those pumps were bolted to the base of the influent gallery, which is basically 2 stories down underground. When you go to the plant and you look, there's the Bilco doors that are just sitting out there. Down below there's a considerable amount of infrastructure. And so when those pumps clogged, people had to go down in the hole, clear them, put everything back into operation. Working with the operator, the town engineer, our staff engineer came out from the Water Authority. We were able to help them to reorganize that area so that the pumps could be pulled up in a more typical fashion so that they could be managed from the surface and didn't make it an emergency situation. You may remember that particular clogging that occurred, and there would be large suction trucks out in the road keeping the fluids from reaching the plant so that the men could go down in the hole, or people, workers, to go down and address that issue. Additional components, at the end of your sewage treatment plant, there are 2 components that are important to getting the right quality of effluent. You have a sand filter, and through retraining the operator with Water Authority staff, we were able to revitalize that and avoid a major improvement to that sand filter. Moving downstream from there, there's a chlorine contact location where you add products to disinfect the water before it goes out into the stream, and a hole had developed in the bottom of that particular section of the tank, and so the fluids were not reaching the outside of the discharge point. Working with the operator, the town engineer, and our staff engineer, we came up with a plan to pour concrete in the bottom of that tank, as well as use certain sealing products and marine grade plywood with carriage bolts to kind of hold the walls together so that you could again move it forward. There are other sections where there are tanks. Remember, we talk about the equalization tank, and I'm sorry if I'm boring you. This is like my favorite thing to talk about. But the last one, the equalization tank, has a sludge tank on the other side. There are 2 different processes, and in that tank wall there are rents in it, and the fluids go back and forth. And so when you have the initial fluids coming in, the chemistry is greatly affected by the fluids that come from that sludge holding tank. And so, although we have not applied a mechanical solution to that at this point, the operator has been trained to keep the levels in both tanks at the same level so that you don't have crosstalk going across and upsetting the entire process of the facility. So these are some of the emergencies that you don't necessarily hear about, that through the town's contract operator, the town engineer, and the Water Authority working with those groups, we've been able to address those things and keep the plant operating, you know, within your current operating budget while using some extra fund balance. Other things will break, and those will need to be addressed, but those are the kinds of innovative professional solutions that our group can bring to your system, working with your contract operator and, at times the town engineer. So anyway, my 2 cents.
Well, what I was more concerned about was,
If we know, okay, in 5 years, 10 years, we're going to replace it, you can go through that whole process. But we're all talking like, this is within, this close to just collapsing. If that happens, we're 2 years away from a new system.
There,
It would just seem like we'd want to have plans on the shelf,
Mhm.
ready to go, so when it went, we could go to bid.
So
Which maybe break up the process a little bit, and maybe,
2 years from now.
So a little bit more information about your plan. The equalization tank is the one that we're most concerned with at the moment. It is definitely, going to fail at some point, and that sludge holding tank could, be into your EQ tank. It's a bad situation. We have put on the paper napkin drawing board plans to run that equalization tank just as it's equal for its purpose there. And then the sludge could be moved to a used tank that might be sited temporarily behind the facility. So you could separate those two processes and continue using the equalization tank. We might be able to use other products such as concrete to temporarily fix that equalization tank. When you look inside your treatment plant, you have clarifiers. There's primary and secondary. In between there, you have that rotating component, the RBC. There are actually 2 trains. So if one side fails, and they have in the last year or two, each one has had an issue. The media that's on the contactor has come off and slopped. The bearings that keep the unit spinning with all that weight that comes from the growth on those the devices, those have failed and been replaced, and one I believe twice. We're seeking to replace a motor at this point. These are those kind of little emergencies that are going to keep happening. The tanks temporarily can be patched together, and we'll keep doing that if we're asked to come in, and the town will continue doing it. But these are things that we do have plans. We are thinking about it, and they can't be patched forever, and that's why we need to get started on the solution for the treatment plant. I hope I've answered your question. Maybe a little too much, but excellent.
And that's really what I just wanted to say. We do a lot of work with a lot of different communities, and Pinebrook is not a big community, and this turnout is fabulous. And the amount of energy from Wayne when we were out there, when I say we had a long day, he was out the whole time we were out there. So believe it or not, I mean, this is really to have this much desire to understand what's going on in the system, and a representative who he was really passionate about what was going on everywhere and helped us as far as the engineers and the authority tremendously. So I just wanted to say from our perspective, we really appreciate having a community and representative that was so interested in being an assistant, providing assistance and providing information. So we really appreciate that quite a bit. So thank you, Wayne.
I just wanted to say I had the privilege of being part of a volunteer committee that Aileen pulled together back about a year ago. And so I've been involved with this in a volunteer effort right from the start. And I have been so impressed with not only the help of Bridget and Jonathan, who have put hours into this when, we'd have our early meetings. Aileen was there, Dave Ray, Hannah at some of them. The cooperation was just fantastic. When we got involved with Aaron and Paul, and when Aaron talked about coming down to in March for the inspection, she brought a whole team with her. She had people climbing up ladders onto the roof and checking the eaves and the roof. There was the safety expert. There was an electrical engineering guy. I don't know, there were probably about 6 people, I think, that you brought down at that time.
Yeah, that's correct. It wasn't just me. We had a safety expert. I'm so loud. They can hear. They didn't even start beeping me. A safety expert, a structural engineer, an electrical engineer. I had another component process engineer with me. Paul. I feel like I'm missing someone. So we came down like in a swarm, and while someone was doing one thing, someone was doing something else, and And then we all stood around and watched the structural engineer up on the ladder in those trusses and waited to see what was going to happen. So, it was a big group of us that came and investigated the plants.
It was fun to watch Aaron troop through the snow to get into the well sites also. But no, they're a very professional group, and I have a lot of confidence in the study that they have provided us, and moving forward, I think we're going to be in good shape. Thank you all.
Continuing the thank yous, I'd like to thank a couple other individuals that have been, a great help to the process, and obviously contractors with the town, but VRI with their operations. We have Mark Rao, who's here representing their operational team. Also at the beginning, Dale Post was an integral part of the process, and then the town engineer with Morris Associates as Pete Sotero has been invaluable to the town as well as this process. So I'd like to thank all those individuals and of course the town board.
Just thank everyone for coming out and look forward to future involvement. If anyone would like to talk about it with myself, you can give me a call, 229-5111, extension 8, or send me an email, aroar@hydeparkny.us. So, we've laid out the process. I think that we've all discussed the complicated nature of this, but I feel confident that we have a good understanding and a plan going forward. So, again, we look forward to refurbishing the plant or replacing the, refurbishing for the interim long-term replacement. So, oh, sure, go ahead.
Can I just ask you, are you optimistic, this little timetable up here, are you optimistic by the end of February that those things will all happen?
I am. I think it's important. We've heard numerous times, time is of the essence. We might have to add a special town board meeting because we have one scheduled for the 9th and the 26th. So we might need to add an additional one just dedicated to this. And that's, it's something that it's been a long time in coming. We had heard the news that we'd received it, and, many months transpired before we were able to get going. So, we want to move ahead. It seems important. So thank you, really wonderful work, and definitely to the Water Authority and VRI for patching this sewer system together until we can get a new one. So thanks again, and good night.
Stand by the pictures.